Ever stop to think that, like, everything, I mean, like your phone, Netflix, even robots, you know, those ones that build cars, they all run on code?
Yeah, it really is amazing.
Yeah, so today we're going, like, deep, deep, deep into that world.
A deep dive.
Yeah, deep dive into computer programming and algorithms.
So uncover the secrets.
Yeah, uncover all the secrets, right. And our guide for this deep dive is this lecture called Basics of Computer Programming and Algorithms, Unraveling the Code of Modern Life.
Catchy title.
Right. And it's really been like our cheat sheet to understanding how computers think.
Absolutely.
And you won't believe this, one of the things I learned,
What's that?
that the first computer programmer was a woman, Ada Lovelace, back in the 1800s.
Yeah. Ada Lovelace was incredible, like way ahead of her time.
Totally.
And her work, it's like the basis for so much of what we see in computer science today.
Okay, but before we get too far ahead of ourselves, let's start at the beginning, okay?
Sounds good.
What exactly is computer programming?
You know, it's pretty simple at its core.
Oh, okay, good.
Programming is just giving instructions to a computer,
Okay.
like writing a recipe. But instead of using flour and sugar, we use code.
Code. Okay, so these instructions, they're written in some special language that the computer can understand.
Exactly. These programming languages, they're like translators
Okay.
between our human logic and the computer's language.
And the computer's language is?
Which is binary code.
Binary code.
It's just zeros and ones.
Zeros and ones. Oh, wow.
Yeah.
That's wild that something so complex can be boiled down to just those 2 digits.
It is pretty wild.
So are there a lot of different programming languages?
There are a bunch, yeah. And they're organized kind of like a hierarchy.
Okay.
At the very bottom, you've got machine language, the raw zeros and ones.
Oh, okay.
The computer understands directly. Then there's assembly language,
Okay.
which is a step up. It uses short codes to represent instructions.
Uh-huh.
And then at the top, we have high-level language, much more human-readable.
Okay, so most programmers work with these high-level languages then?
Exactly. Yeah.
Okay.
They let us express like complex ideas without getting lost in all the technical details of the hardware.
Oh, that makes sense.
Popular ones include Python, that's known for being beginner-friendly,
Okay.
and C++, which is really good for speed and efficiency.
So it's all about picking the right tool for the right job.
Exactly.
I bet there are all sorts of traditions and, you know, inside jokes in the programming world.
Oh, absolutely.
Like what?
Well, almost every programmer starts by writing a simple program
Okay.
that displays "Hello World" on the screen.
Hello, world.
It's a rite of passage.
It's like their first word.
Kind of, yeah.
That's pretty cool. Like, okay, computer, let's do this.
Exactly.
All right, so we've covered the basics of programming. How about algorithms? Are they just for computers too?
Actually, you encounter algorithms every day,
Every day.
even outside the digital world.
Really?
Oh, yeah.
So an algorithm is just a fancy word for a set of instructions.
Exactly. A step-by-step procedure for solving a problem.
Okay.
And you know where the word comes from.
No.
The name of a Persian mathematician,
Oh, wow.
Al-Khwarizmi, who
Mhm.
lived way back in the 9th century.
Wow, so the concept of algorithms has been around for centuries.
Absolutely. Yeah.
Huh?
The principles behind them, they're timeless.
Wow.
At its core, an algorithm has 3 main parts:
Okay.
input, process, and output.
Okay.
So you have the input, the information you feed in,
Uh-huh.
the process, the steps the algorithm takes to do its work,
Okay.
and then finally you get the output, the solution, or the result.
So kind of like a chef taking ingredients, following a recipe,
The process.
and producing a delicious dish.
Exactly.
I like that.
And, you know, there are classic algorithms that are surprisingly simple,
Okay.
yet incredibly powerful. Like the Euclidean algorithm.
What's that?
It's used to find the greatest common divisor of 2 numbers.
Okay, I'm not a mathematician, so explain that to me like I'm 5 years old.
All right. Imagine you have 2 lengths of rope, and you want to cut them into the longest possible pieces of equal length.
Okay.
The Euclidean algorithm helps you find that largest possible equal length.
So it's a method for finding like the biggest common factor.
Exactly.
Okay.
And it's this repeating pattern, a set of steps,
Okay.
that eventually leads you to the answer.
And that's been used for centuries.
And it's still relevant today.
That's amazing. Okay, so we've laid the groundwork with algorithms. Let's get back to programming for a minute.
Right.
Talk about some key concepts that make it all work, like variables.
Sure.
I feel like I've heard that term before.
You probably have.
Maybe back in like algebra class.
Yeah, think back to all those X's and Y's.
Oh, yeah.
In programming, a variable, it's like a container
Uh-huh.
that holds a piece of data.
Data, okay.
And each container has a label, a data type, that tells you what's inside.
So it's like labeling a jar as cookies or coffee beans.
Exactly.
I like that.
Common data types include integers,
Okay.
which are whole numbers, floating point numbers for those with decimals,
Okay.
strings for text,
Okay.
and booleans,
Yeah.
which represent true or false values.
Okay. So it's like creating a digital profile with labeled boxes
That's a great way to think about it.
for each piece of information.
Exactly. And by assigning those specific data types,
Okay.
we make sure the program handles the data correctly.
So we've got our data neatly organized, but how do we actually make the program do something with it?
That's where control structures come in. They're the commands that dictate the flow of the program,
Uh-huh.
allowing us to make decisions
Okay.
and repeat actions based on certain conditions.
Okay. I'm intrigued. Tell me more.
There are two main types: conditional statements,
Okay.
and let the program choose different paths depending on whether a condition is true or false.
Oh, okay.
Imagine a program that checks a user's age.
Uh-huh.
If they're over 18,
Okay.
it grants access to certain features.
Okay.
Otherwise, it restricts access.
So it's like a digital bouncer checking IDs at the door.
Exactly.
Okay.
Now, loops are like the workhorses of programming.
Oh, okay.
They let us repeat a block of code multiple times.
So instead of writing the same code over and over, we can just use a loop.
Exactly.
Okay.
Imagine you wanted to print the numbers 1 to 100.
Uh-huh.
You wouldn't want to write 100 separate print statements.
Yeah.
The loop would handle that effortlessly.
That's a huge time saver.
It is.
Let's talk about functions.
Sure.
You mentioned them earlier.
Functions are essential for making code reusable and modular.
Okay.
Think of them as like mini programs within a larger program.
We're breaking a big task down into smaller chunks.
Exactly.
Okay.
Each function performs a specific task,
Okay.
takes inputs, does some operations, and returns an output.
Like a little factory.
Exactly.
With a very specific job.
Yeah.
Okay, can you give me like a real world example of a function?
Okay. Imagine you're building a website
Uh-huh.
where you need to greet users by name.
Okay.
You could write a function called greet
Okay.
that takes a person's name as input
Uh-huh.
and returns a greeting message.
Okay.
So if you call the function with the name Alice, it returns hello, Alice.
Okay.
And you can use that same function to greet any user. Just provide their name.
That's like a customizable greeting card
It is, yeah.
built right into your website.
Exactly. And the beauty is you can use that greet function anywhere,
Oh.
making your code cleaner and easier to manage.
So it's like having a well-organized toolbox
Exactly.
where every tool has its own purpose.
You got it.
And now I'm ready to see how all that stuff actually translates to real-world applications.
All right, get ready to be amazed. Let's start with something that might sound kind of simple,
Okay.
but it's actually super important in the world of computers: sorting algorithms.
Sorting algorithms, I gotta be honest, that doesn't sound too exciting.
Oh, trust me, it's way more interesting than you think.
Okay.
Imagine you're trying to find a specific book in a library with like millions of books, but they're all randomly shelved.
Yeah, that sounds like a nightmare.
It would take forever,
Yeah.
right?
Yeah.
Sorting algorithms arrange data in a specific order.
Okay.
Makes it much easier to search, analyze, and manage information.
Okay. I see why sorting is so important then, but how do these algorithms actually work? I mean, are there like different types?
There are tons of sorting algorithms, yeah.
Okay.
Each one has its own approach and level of efficiency.
Okay.
A simple one is called bubble sort.
Mhm.
It compares adjacent items in a list and swaps them if they're out of order.
Okay.
It's like slowly bubbling the largest items to the top.
So it's a very visual process.
It is, but it's not the most efficient, especially for really large data sets.
So what do you use for those?
For those, we've got algorithms like merge sort and quicksort. They use a divide and conquer strategy, breaking the list into smaller chunks, sorting them, and then merging them back together in the right order.
So it's like organizing a giant bookshelf
Exactly.
by sorting each shelf first and then combining them. I like that.
Yeah, and these algorithms are super fast. Even for massive amounts of data, they're used in everything from search engines to databases to e-commerce websites.
Wow, sorting is everywhere. So it's all about making data more manageable and accessible. What other real-world problems do algorithms help us with?
Well, let's talk about pathfinding algorithms.
Okay.
These are the brains behind GPS navigation and AI.
Oh, yeah, I use GPS all the time. It's crazy how it can find the best route even when traffic is a nightmare.
Right, well, that's the power of pathfinding algorithms. One of the most popular is called A or A star. It's like a really smart navigator that considers both the distance to your destination and any obstacles in the way.
So it's not just finding the shortest route on the map.
Right.
It's finding the shortest route that you can actually take.
Exactly. A takes into account things like traffic road closures, even speed limits to
Hmm.
find the best path.
Man, I had no idea. We relied on algorithms so much in our daily lives.
We really do, and they're only getting more sophisticated and more integrated into our world.
Okay, but even the smartest algorithms can make mistakes, right?
Yeah.
What about debugging? I've heard programmers talk about that. What does it involve?
Debugging is a crucial part of programming.
Yeah.
It's all about finding and fixing errors or bugs in the code. And actually, the term bug has a pretty interesting origin.
Really?
Yeah, back in 1947, a moth got stuck in a relay of the Harvard Mark II computer.
A moth.
A real moth caused the whole thing to malfunction. Grace Hopper, who was a computer science pioneer, she taped the moth into her logbook with a note that said, "First actual case of bug being found."
Wow, so a literal bug was the first computer bug. That's a great story. I imagine most bugs aren't that easy to find, though.
You're right. Debugging usually involves carefully going over the code, testing different scenarios, and using special tools to track down the source of the problem.
Sounds like detective work mixed with solving a puzzle.
It definitely can be, but it's also really satisfying when you finally isolate and squash that pesky bug.
Okay, so once you've gotten rid of all the bugs, is the code ready to go?
Almost. Usually there's one more step: code optimization.
Okay, optimization. What's that?
It's kind of like fine-tuning the engine of a car to get the best performance. Code optimization is about making the code run faster, use less memory, and be more efficient overall.
So squeezing out every little bit of performance.
Exactly. But there's also a famous saying in programming:
What's that?
premature optimization is the root of all evil. It's a good reminder to focus on writing clear, correct code first, and then worry about optimizing it later if you need to.
That's a good point. Don't get bogged down in the details too early on. Speaking of complex systems, how does programming connect to AI?
AI is heavily dependent on algorithms,
Hmm.
algorithms that can learn from data and make decisions or predictions.
Okay.
There's a whole spectrum of approaches, from simple decision trees to these super complex neural networks that try to mimic how the human brain works.
Neural networks, those sound really complex. How do those work?
They involve layers of interconnected nodes
Okay.
that process information and learn patterns.
Okay.
They can do amazing things like image recognition or natural language processing.
It's mind-blowing how these algorithms can seem almost human.
It is. But it's important to remember that AI is still pretty young. There are a lot of challenges ahead as we develop and refine these technologies.
We've come a long way from the basics of code to exploring how algorithms power everything from sorting data to AI.
It's been quite a journey.
It really has, and now in this final part, I'm excited to see how this all connects to the bigger picture.
Well, get ready. They're transforming pretty much every industry you can think of: healthcare, finance, transportation, entertainment. The list goes on.
Okay, so give me some specifics. How are algorithms changing healthcare, for example?
Well, in healthcare, they're being used to analyze medical images, predict patient outcomes, even personalize treatment plans.
Wow.
Imagine algorithms helping doctors detect diseases earlier and more accurately.
That's incredible. It sounds like they're becoming really powerful tools for medical professionals.
They are. And in finance, algorithms are being used for everything from fraud detection to something called algorithmic trading, where computers make super fast trades based on market data.
Wow, so algorithms are making decisions about our money. That's both impressive and kind of scary.
It's true that there are concerns about algorithms making biased or unfair decisions.
Right.
But it's important to remember that algorithms are just tools.
Okay.
They're only as good as the data they're trained on and the people who design them.
That makes sense. Human oversight is still crucial. What about transportation? Self-driving cars are a hot topic these days.
Yeah, self-driving cars are a perfect example of how algorithms are revolutionizing transportation. They rely on complex algorithms to perceive their environment, make decisions, and navigate safely.
It's pretty wild to think about all the possibilities. What other innovations are on the horizon? What's the next big thing in algorithms?
One area that's getting a lot of attention is quantum computing. Still early days, but quantum computers could potentially solve problems that are impossible for regular computers to handle.
Quantum computing, that sounds like science fiction.
It does, but it's a real field of research, and it has the potential to revolutionize everything from drug discovery to material science to AI.
It's clear that programming and algorithms aren't just technical concepts. They're shaping the future of society. But with all this power comes a lot of responsibility, right?
Absolutely. We have to think carefully about the ethics of algorithms
Mm.
and make sure they're developed and used responsibly.
I couldn't agree more. We need to make sure that these technologies benefit everyone, not just a select few.
Well said. The future of algorithms really depends on us.
Yeah.
We need to be informed and engaged in shaping how these technologies are developed and used.
This deep dive has been such an eye-opening experience. It's helped me realize that programming and algorithms are much more than just lines of code.
Yeah.
They're tools that can solve problems, create opportunities, and raise important questions about the future.
And that's what makes this field so exciting. It's constantly changing,
Yeah.
always pushing the boundaries of what's possible.
Absolutely. So as we wrap up this incredible deep dive, what's one thought-provoking question our listeners can think about as they explore this world?
Here's one. As algorithms become more and more sophisticated and more integrated into our lives, what does it even mean to be human in this algorithmic age?
That's a great question. It makes you think about the whole relationship between humans and technology.
It really does. And it's something we need to keep in mind as we move into the future. Thanks for joining us on this journey into the world of programming and algorithms.
It's been a pleasure, and to all our listeners out there, keep learning, keep asking questions, keep exploring, and until next time, stay curious.